Continuing on with vectors, this time we're talking about a unit vector, and a unit vector is really kind of like something that has a magnitude of 1. And so we can take vector v and divide it by the magnitude, and that gives us the u vector, which we're going to call unit vector. So if we look at an example, it says find a unit vector in the direction, it's u is a unit vector in the direction of v. So that's what we are looking at, finding the unit vector in the direction of v with the vector being negative 2, 5, and verify that the result has a magnitude of 1. So the first thing I'm going to do is try to find the magnitude. So I'm going to say, all right, the magnitude of u is, again, it's basically the distance formula. So just looking at, maybe I'll again, if we have negative 2 squared plus 5 squared, that gives me 4 plus 25, which gives me a magnitude of 29. So now I'm going to take my vector, which again was negative 2, 5, put it on top. I'm using this formula right here. And I'm going to put on the bottom square root of 29. And then again, if I think about splitting it up, I'm going to say, all right, the u is equal to, again, just inputting my square root 29 into my vector. I come up with this. So now I'm going to actually take the magnitude, or find the magnitude of this new vector, which we just found right here, and we're going to see if that equals 1. So as I'm going through and plugging in, okay, I know that to do this, I need to use the distance formula. So I am going to square I would use the distance formula if it was in the other phone. Because it's in our vector form here, we can just plug in our numbers over square root 29, and then we need to square that. And then over here, we've got 5 over square root 29 squared. So again, simplifying, negative 2 is 4. A square root and a square are opposites. So I'm left with this. 5 squared is 25. And again, how do you undo a square root? You square it. That gives me square root 29 over 29. Therefore, we get the square root of 1, which is just 1. So after finding the unit vector, I verified that the magnitude was 1, which again tells me that yes, it is actually in fact a unit vector. We have 2 standard unit vectors, and they're I10 and J01. And then again, we can multiply that by V1, which we're going to call horizontal, or V2, the vertical components. And we could get any sort of linear combination out of that if we multiply them. So again, let's look over here. The vector sum V1I plus V2J is called the linear combination of vectors I and J. And we can write any linear combination in sort of this form. So let's look at an example. Let u be the vector with initial point 2, negative 5 and terminal point negative 1, 3. Write u as a linear combination of the standard unit vectors I and j. So my first sort of step, my first idea is, again, let's combine u and let's combine our points so that we get a vector. And so I'm going to do negative 1 minus 2, 3 minus negative 5. Again, minus a negative really gives me a positive right here. And now I'm thinking, all right, how do I do the second part? How do I write it as a combination of the standard unit vectors I and j? And so I can show this vector by saying, all right, writing it in the form that we just talked about over here, multiplying any vertical with V2 and any horizontal with V1, I would say it's negative 3i plus 8j. So I'm, in a sense, saying the same thing, whether it's in this form or whether it's in a linear combination form right here. let's do another example. Let u equal negative 3i plus 8j, and let v equal 2i minus j. Find 2u minus 3v. So again, basically kind of just plugging in what I know. I'm going to say, all right, 2 every time I see a u, 3i plus 8j, minus 3, 2i minus j. And then I'm going to use the distributive property, again, to every single term. Have to do it twice. And that's going to give me negative 6i plus 16j minus 6i plus 3j. And I do have some things that can sort of cancel out or combine, and that is, can't really cancel out, but I can get negative 12i plus 19j when I combine like terms. So again, getting those linear combinations, and then also applying sort of scalar multiplication, scalar subtraction, adding on to stuff that we've already worked on. If u is a unit vector, the terminal point of u lies on the unit circle. So again, kind of looking at it like this, all right, if it's a terminal vector, which is what we talked about at the beginning, x is like cosine, y is like sine. So I can sort of think about it like, okay, theta is the directional angle, or theta is where I am going. So if v has the same direction as u, we can basically say find the magnitude, and then input cosine and sine in, and then sort of go through and use the distributive property, and then write it in that linear combination form that we're used to. So let's try an example of that. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal. Now remember, it says 100 miles per hour, but to have this unit vector, we need to have a magnitude of 1. So again, that would be 100 miles in 1 hour, which we can kind of represent. Again, I'm going 30 degrees below the horizontal, and I'm flying at 100 miles an hour. But really, because again, I'm starting here, I'm 30 degrees below the horizontal, but this right here is 180. So 180 plus 30, this is really like 210 degrees. So now I'm going to sort of take that formula. Again, I just found theta. I'm going to take this formula up above, and I'm going to say, all right, the magnitude of v is multiplied by cosine theta I, cosine of 210 I, plus sine of 210 I. I need to also include the magnitude. There we go. Sine of 210 I. And because we have this right here, we can kind of input or substitute. We know that our unit vector, our distance of 1, is 100 miles an hour. So I'm going to rewrite it as 100 cosine 210 I plus 100 sine 210 I. Using my unit circle, I can determine that what is cosine of 210? Cosine of 210 is negative square root 3 over 2. And what is sine of 210? It is negative 1/2. Can't forget my eyes. And now I can actually simplify. So again, 100 divided by 2, I'm going to go ahead and simplify that to say 50, it's negative, square root 3i, plus 100 divided by 2, again, also negative 50i. So that one doesn't even have a radical. Or excuse me, it should be j here. So again, if I were to write that in my sort of vector form, I would get, I would say this is negative 50 square root 3 and negative 50. Okay, let's keep going. If v equals a times I plus b times j. The direction angle for v is determined by the tangent theta of b over a. So what does that mean? That means that, again, if we're trying to find what direction we are going, we can sort of use this idea to help us. So first thing I'm going to do is find the magnitude and direction of each angle. Well, I'm going to start by finding the magnitude. That's kind of how I like to just sort of always go about starting the problems. And I'm going to say that, all right, because I'm in this form, my standard, I can just say, all right, square root 3 squared plus 3 squared. 9 and 9 gives me square root 18. Okay, so I'm working with a tangent, or excuse me, a square root of 18 for the magnitude. And to find the direction, I'm going to use this up above and say, all right, fine, my tangent of theta is going to equal, well, b over a is 3 over 3, which would just be 1. So tangent of theta equals 1. And where do we find tangent equal to 1? Well, we could get it at 225, or we could also find it at 45. Again, there's two answers, 45 or 225. However, because we have a positive x value and a positive y value, we know that according to where our unit circle is, our answer can only be in quadrant 1. Therefore, our final answer has to be 45 and cannot be 225. All right, one more example. Again, find the magnitude and the direction. First things first, to find my magnitude, I'm going to take my values, square them, plus, again, make sure that when you square that negative, it cancels out. This gives us a nice number, square root 25 equals 5. Now I'm going to say, all right, using the formula above to determine the direction, tangent of theta equals negative 4 over 3. Again, this is A, this is B. All right, so I'm at the think, where on my unit circle does theta equal tangent of negative 4 over 3? And in fact, it does that at, well, I can't find that one on my unit circle, but if I type it into my calculator, I'm going to get, let's do that. Inverse tangent of negative 4 over 3. And we get about negative 53.1. Now, again, I'm thinking, my answer is negative 53.1 degrees. That doesn't really make too much sense. So what I'm going to do, because it doesn't really make sense, I'm going to add 360 degrees. I'm just going to go around my circle one more time. I'm going to go complete one whole wrap around of my circle, and I'm going to end up in the exact same spot. So negative 53.1 degrees is actually 306.9 degrees. They are the same thing.